Welcome to today's lesson on misleading graphs. This is probably one of my favorite lessons to teach. Actually, every single lesson is my favorite, obviously. Right? And this is a very practical one because oftentimes in media, hey, we see a lot of graphs, but a lot of times they're very, very misleading. Right? So we have to be able to identify when a graph is not really showing what we're supposed to see. Right, so there are three common things that we want to look at when we see a graph. We want to make sure that its axis is not displaced, right? Because sometimes the graphs don't start at zero. Right? Remember in the exercises we did in the past in the graphing unit, that will always start at zero. Right? But not all graphs do it. Sometimes they have irregular scales. Right? It doesn't really go up by one each time. Sometimes it can go up by different amounts. And another common one is the exaggerated use of area, right? Where the height and the width of those graphs are very, very different, even though they don't need to be. So let's look at this one here, for example. All right, if you look at the first graph, we can see, wow, look at that. That's such a big difference here, right? Going from A to E, right? We can see right away that the bars are different heights, and they matter by quite a bit. But as we can see here, it didn't start at zero. It started at 900 instead. And as you can see closer, this whole thing is only between 900 to 1000. But so if we use a more proper scale, right? If we were to start at 0, you can see here that because it's only going from 900 to 1000, right? The change isn't actually that much. Right? Because if you can imagine, when we zoom into this little section here, right, this is what we get. Right, but if we zoom all the way out and start at 0, it's actually not a huge change. Right, so as you can see here, that well, this graph doesn't have any context. It's just a random graph with some random numbers that don't really matter. Right, but if we give it some context, you can see some really funny things. This is probably one of my favorite graphs of all time. We got average female height per country, and as you can see here, I don't know what they're doing with this graph. Right, I'm sure the data is accurate. Right, so first of all, they didn't start at 0. They didn't start at 0. They started at 5 feet and went only up to 5 feet 5 inches. So this whole range of differences is only 5-inch difference. 5 inches is not really a lot, and looking at this graph, they make it really seem like there's a lot. Right, and as you can see here, they really exaggerated the area. Right, there's no reason for those women to be this different in size. Like, look at this. This is India, by the way. What is going on over there? I've seen Indian women. I've seen Australian women. I've never seen those two being this different. Right, so this is a really exaggerated data here. Right, and another example of exaggerated data will be something like this. Once again, I'm sure the data is accurate. Right, I'm sure that between 1997 and 1995, they seem to be around the same, right? They probably sold the same amount of houses in both years. But because of this perspective change, it seems like there are more houses that were sold in 1995. Right? Even though the houses sold in 1997 is probably around the same. Right? So I think I kind of imagine here, by playing around with the size and the scale, we can get pretty different results. Right? Maybe for this one. This was just really funny. Just a tiny Indian woman compared to the rest of the world. Right? We can see some more examples here. Right? When we add more context, you can kind of see that a lot of graphs can lead to some agendas. Because right here, there's not a huge difference. I mean, it looks different, right? But we started at 80,000. And in 1 year, the average housing price, right, in 1 year, the average housing price went from 80,000 to 82,000. So like, it's not really that different. It's only 2,000 more. I mean, yeah, it's 2,000. That's a lot of money, but it's not really a huge gap when it comes to $8,000. But also, that's insane how much cheaper it was back then. Right? We just know we can spend that much money. I just spend that much on a car now. Right? So graphs like this, based on the context, might have some sort of agenda. Right? The reason why they want to make this gap so big is to show like, oh, look at this. Look how much look how much housing has increased this year. Right? And of course, as you can imagine, a lot of those graphs are deeply political. Right here we got percent who agrees to court here. Right. We can see here that the Democrats there's a lot more Democrats that have agreed relative to Republicans. But if we look closer, can't really see here. It's a little dark. Right, but if we look closer, there's only 8 more compared to Republicans. Right. We got 62 Democrats and 84 Republicans. Right, there's only 8 more. However, it looks a lot more than what should have been. Right, and as you can imagine, there might be some sort of agenda right here as well. Right, and this agenda can be swung both ways for both parties, right? It could be a law that's great for the Democrats, and then Republicans say, "Oh, look how much more they voted," right? For example, and then it could be a law that really that's detrimental to the Republicans, right? And then they can say, "Oh, look how much more Democrats have voted," right? So you can really get some agenda out of this. And then for those two graphs up here, I just grabbed it randomly from the internet, but this is an actual real graph, right? This is from an actual study, right, from the Florida Department of Law Enforcement. Right, so this is real. And right here, this is the number of murders committed using firearms. And as you can see here, in 2005, when they enacted your stand your ground law, you can see, oh, look at that, that's nice. The stand your ground law has decreased the number of gun deaths. But if we look closer, right, the y-axis is flipped. Right, normally, when we see a decrease like this, that means the number is going down. Because normally, our graph, right, we start at 0 and then we go all the way up. However, in this case, we actually started at 0 and went down. So the lower we go on this inverted y-axis, the bigger the number is. So even though there's a decrease here, right, there's actually more death. Right, there's actually more death happening after this law was enacted. Right, so as you can imagine here, by making this graph, and again, that's a real graph from the Florida Department of Law Enforcement, could be some sort of agenda right there as well. Right, probably to do with the gun policies and all. Right, so it's very careful to always look at a graph and think for ourselves first. Right, and then the last one, hopefully you don't really see this that much. It even took me a while to find an example like this. Sometimes we get an irregular scale. Okay, so no more agenda here, it's just the weight of a puppy. Right, as you can see here, we went up by 1 kilo at a time. But as we go further, as you can see, we started adding by 4. Right? And so this is an example of an irregular scale. But we gotta commit to 1, right? Yeah, if we are scaling by 1, we're going by 1 for the whole graph. We cannot just switch to going up by 4 midway. Right? But again, irregular scale, don't really see it that much. The most common ones you will see is, again, things like not starting at 0, making the graphs look exaggerated. Exaggerated area, this is still so funny. Exaggerated area, especially in politics. As you can see, an exaggerated area really makes you shift your perspective if you don't read the headlines. And of course, hopefully we don't see this ever again, but you get something like this where they flip the y-axis to make it look like something is decreasing when something should be increasing. Okay, yeah, just a few little fun examples that I saw. So with that being said, that's pretty much it for today's short little lesson. So good luck practicing.